Artificial intelligence is the idea of getting machines to achieve human-level intelligence. Machine learning is a field of AI that's about learning from data to extract rules and derive patterns instead of being explicitly programmed. And deep learning is a specific type of machine learning that's becoming recently very good at dealing with high-dimensional data like text, audio, and video. And you might ask yourself, what does this have to do with ArcGIS? We have machine learning tools in ArcGIS that you can use today, tools that can help you make predictions, clustering, or even classification of imagery. In addition to that, we integrate perfectly with deep learning and machine learning frameworks as well, either the open source one, like TensorFlow, PyTorch, Theano, or the commercial ones, like IBM Watson, Azure Machine Learning, or others. We do this through the Python API and the R-Bridge. And today, I want to show you two great examples of integrating with deep learning engines. So deep learning is becoming really good with computer vision. It can detect and see what we humans can see. Anything that a human can detect under 1 or 2 seconds, it can do that. And this is a very interesting problem, which is about detecting oil pads. So what we are seeing here on the screen is a lot of those oil pads. And from a competitive analysis perspective, a lot of companies want to understand where are those oil pads, where are they spreading, very quickly. So the data that we have is not always accurate from the counties, so they want to do this from satellite imagery. They want to find those oil pads. And as you can see, there is a lot of them right here. So maybe we can use deep learning for that. So if we go to this area here at the Permian Basin and start doing some sort of analysis, we're going to find that there is different oil pads appearing, as you can see, right? So these 3 here, those 2 upwards here. So we need to do something about that. Those green points represent the registered oil pads. But as you can see, some of them are not registered. So let's start using deep learning to detect those. The first thing that you need to do when doing deep learning is to train a model. And to train a model, you need some examples. We have created a new tool in ArcGIS called Export Training Data for Deep Learning. This tool is going to help you prepare the training data for deep learning. The tool is going to take 2 inputs. The first input is going to be the raster, and the second input is going to be the feature class that we have. Luckily, we have a feature class here that you guys can see. And when we click Run on this tool, this is going to be the output. Those image chips are exactly what we need to train a deep learning model. So now we can start training. Today, we have seen ArcGIS notebooks. And one thing I want to announce is that we have the capability to train deep learning models inside ArcGIS today. So we are importing the Python API. This is a notebook server, ArcGIS notebooks. And we are using ArcGIS.learn. ArcGIS.learn is going to help you do different things with deep learning, one of which is training deep learning models. So if we scroll down here, we're going to find that we are importing single-shot detector. It's a very famous library for developing and training deep learning models. And in literally a single line of code, we are training a deep learning model using the image chips that we have just produced using the export training data for deep learning. So what about using this model that we have trained? So if we get back here, we're going to go to the next area. So we have a new tool called Detect Objects using deep learning. If you search for it here, you're going to find it in the geoprocessing. So Detect Objects is going to help you consume deep learning models inside ArcGIS. Again, it's going to take 2 inputs. So the first input is going to be the raster. The second input is going to be a wrapper around the model. We call it Esri model definition. It's just a file around the model. The output from this, when you run it, is going to be the detections. So this is going to run the deep learning model inside ArcGIS. It's going to detect all of those oil pads. As you can see, they are literally everywhere. And we are not really interested in all of them. We are just interested in the ones that are not registered, the ones that are not in the data. So the blue ones here represent those. So if we have a closer look at this, we're going to find that there is a lot of those, right? Isn't this beautiful? The idea of leveraging AI without the need to have a PhD in data science or deep learning, we have created all of those tools for you guys to help. But this is not the end of the world. The kind of edge that we have as a company when dealing with AI is what's happening after AI. What are those pieces that we can connect on the top of the model? So what about doing some spatial analysis on this? What about understanding the trend of increasing or decrease of those oil pads. So we have done this detection across 52 weeks. For every week, we have got imagery for this week, and we have ran the model on this imagery. And using the time slider, you can start noticing those oil pads as they increase. You can see that some of them appear here. They are represented by the different colors, as you can see in the legend. And as we move the slider, we're going to notice that they are mainly increasing in the lower right part. But if we move it here, we're going to see that there is significant increase in the last period in the upper left part. So this is giving us some insights, not just from a geospatial perspective, but from a temporal perspective as well. What about taking this one step further and applying more analysis? This is a space-time cube, an amazing tool that we have in our machine learning arsenal. So this is going to help us build a cube for every week on a 1.5-kilometer grid. And as we can see, there is a significant number of those oil pads here, and we can filter those easily. For example, I can say, hey, get me all those areas that has 75 oil pads, or any kind of other number. We can even go to this tool and create an emerging hotspot. So the space-time cube enables you to find the emerging and fading hotspots, to find those statistically significant clusters. So not only visualizing the amount of oil pads, but seeing where are those patterns happening. So this is an end-to-end story that we were able to prepare the training data, train a model inside ArcGIS, run the model, do the detections, do temporal analysis, and do machine learning to find the statistically significant clusters, all of which inside ArcGIS. Now, I want to talk about something else here. The problem of road cracks. We're working with a lot of customers who want to understand and define where do we have road cracks, whether they are longitudinal cracks, lateral cracks, or alligator cracks. It's a problem that many of our customers are spending a lot of money on right now, using different tools, some of which is using LiDAR, which I think is going to still be important. But why don't we leverage AI and ArcGIS to find those cracks easily and fast? Let's see how we can do this. So if you have a geotagged video, someone who is driving with a camera like a GoPro or an iPhone or anything, and recording the video that is geotagged, you can detect the cracks from this video. So the first thing that we have done is that we got a training set that was available publicly, about 5,000 cracks. We trained a deep learning model using TensorFlow, and we wanted to apply this model to ArcGIS. So we are importing the Python API here. We are importing TensorFlow, connecting to our GIS, loading the TensorFlow model, and then we're going to start accessing this layer. So while we're doing those detections, we want to add them to a specific feature layer. So we're calling that layer here, and we're processing the model on the video. And I'm going to scroll down here to show you guys the results. So this is the geotagged video, and as you can see, this is a traditional camera. And as the car is moving, the detections happen in real time. Those boxes that you're seeing here are doing the detections for the cracks and recording its location. How can we take this to the next level? By having a beautiful dashboard like that. This is showing the amount of cracks on different segments, and you can see here the breakdown of longitudinal, lateral, and alligator cracks by type. You can even go and do some analysis, click on some of them, see where exactly those cracks are, and take some decisions. Isn't this beautiful? AI is available, ArcGIS is available. Connecting both together helps us reach places that we weren't able to reach before. I cannot wait to see how are you guys going to leverage those new capabilities. Thank you.